My name is Jordan Henry, and I am a mechanical and mechatronic engineering student performing my Capstone project on applications of ambient backscattering technology for IoT security, with my focus being on the development of a novel method to defeat radio jamming attacks. I have been developing a novel method using intelligent ambient backscattering techniques, which allows for a low-powered IoT device to defeat a very powerful jammer by leveraging the jammer's weapon, being its jamming signals. The project supervisor is Dr. Hong Ding and his associates, whom are co-supervisors, as well as collaborator Dr. Michael Behrens. This project was carried out as part of the UTS Innovation Commercialization seed funding for an Australian patent application, with the provisional filed on the 6th of March 2019, and the project led by Dr. Hong Ding. During the project, experiments were performed at UTS Tech Lab and UTS Rapido under supervision of supervisors and collaborator. Radio jamming is the deliberate jamming, blocking, or interference with authorized wireless communications. Importantly, radio jamming attacks can be easily launched by using commercial off-the-shelf products, and thus they can cause serious consequences to human life, especially in mission-critical sectors such as healthcare, military, and transportation. There are some countermeasures proposed to prevent and mitigate impacts of jamming attacks. One of the first well-known methods is escaping. It means finding another communication channel when the current channel is under attack. The second method is fighting. It means the transmitter tries to transmit at a very high power level to dominate the jamming signals. And finally, the transmitter can also hide. It means transmit at a very low power level so that the jammer cannot detect the transmission, or wait until the attack stops. We propose a novel solution which allows a low-powered IoT device to defeat a very powerful jammer by leveraging the jammer's power. The high-level idea of this solution is that when the jammer attacks the channel, the IoT device can utilize the jamming signals as a communication means to transmit data. The two special features of our proposed model are, firstly, it allows the transmitter to transmit data even under very strong jamming attacks. Secondly, the higher power the jammer uses to attack the channel, the greater performance the system can achieve. So, how can we do it? The key technology behind this idea is ambient backscatter communication technology. In particular, when the jammer launches a jamming attack by sending strong jamming signals to the channel, the transmitter can control its impedance matching circuit to reflect or absorb signals received from the jammer. When the receiver receives the reflected signals from the transmitter, it can detect as bit 1, otherwise it can detect as bit 0. By doing so, instead of transmitting data using active RF circuits, the transmitter can transmit bit streams to the receiver right on the jamming signals. The principle of this approach is similar as that of RFID systems. It means bits 1 and 0 are transmitted based on the reflect and absorb states of the impedance matching circuit. Note that at the receiver, in case if the transmitter backscatter or the reflect signals, it will receive both signals, that being signals from the jammer and the reflected signals from the transmitter. Thus, to decode information transmitted from the transmitter, the receiver can use the averaging decoding mechanism as illustrated in these images. The image on the left is the raw signals, and the image on the right is after the averaging process to decode the backscattered signals. The developing prototype has a wide range of applications in practice and can be deployed widely in military telecommunication applications, ensuring continuity and sustainability of critical communications. Furthermore, our prototype can also be implemented in civil communication applications, dealing with deliberate or unintended interferences from coexisting communication systems. Our proposed prototype, consisting of low-cost, low-powered circuits, can be easily integrated into wireless IoT devices. The compact and high compatibility of our prototype is based on the novel idea of using exactly jamming signals for communications, of which any application can benefit from the anti-jamming technology. Backscattering allows legitimate transmitters not to need its own power to transmit data to the receiver. Potential customers from Australia include Australian Defence Force and Optus. And beyond Australia include US Armed Forces, Intel, European Defence Agency, and Qualcomm. We can also approach potential UTS industry partners such as Nokia Corporation, Cisco, Intel, Cubic Defence Australia, DCS Corp, CISRO, New South Wales Defence Innovation Network, and DMTC Limited. We have successfully developed a proof of concept prototype showing the effectiveness of our proposed method. We are developing a low-cost IoT device which transmits information to the receiver using the backscattering of jamming signals. Through experiments, we demonstrated that under a jamming attack, the transmitter can still transmit information to the receiver, successfully transmitting the message, "Hello, UTS." Invention is seen in this project in using extendable antennas or multiple different length antennas to allow for a larger frequency range for backscattering. Performing post-data processing and using Morse code to allow for max data transmission rates. Setting up the IoT device such that it can send any string for testing and prototyping purposes. This is a very cheap, versatile, and compact solution which uses a very small microcontroller and an ambient backscattering device which includes the antennas. This is the Faraday cage which we used for our experiments. Let's have a look inside. Experiment setup for the proposed method. Transmitter is IoT device which can transmit data, messages "Hello UTS" to the receiver, IoT gateway, under a jamming attack by using the right jamming signals. In the experiment, we used a signal generator as the jammer and a spectrum analyzer as the receiver. This is the results where the receiver can successfully receive information transmitted from transmitter. Message transmitted in Morse code. For the future of the project, there will be more testing and prototyping performed, also testing other types of jammers. This technology would then undergo a commercialization stage where we incorporate it into a product which we can then take to industry. With industry partners on board, we can then do further research and development for use in real-world applications.